Welcome back to online class with me, AFM Yusuf, Assistant Professor, Department of Chemistry, Milestone College. How are you, students? I hope all you are fine and very busy with your study. I also hope you are very conscious about your HSC exam. Dear students, today I am going to teach you the chapter 3 of first paper, and the name of this chapter is periodic properties and chemical bonding of elements. Today's topic is MCQ type questions. So, dear students, look at the whiteboard. Which of the following has a linear geometric shape? Students, this is boron trichloride, and the molecular shape of boron trichloride is triangle, and this is water. The shape of water is molecular shape of water is band, and this is methane. All you know that the molecular shape of methane is tetrahedral, and the molecular shape of carbon dioxide is linear. You know that in the structure of carbon dioxide, both of the oxygen atoms are placed at the opposite side to each other, and carbon is at the central point. That's why the molecular shape of carbon dioxide is linear. And here the bond angle is actually 180. So, dear students, the answer will be choice D. Question number 2. Which has the highest bond angle? Students, the choice number A, phosphorus trichloride. The bond angle of phosphorus trichloride is 100 degree, and hydrogen sulfide, the bond angle of hydrogen sulfide is 92.1, and bond angle of phosphine is 93.5 degree, and bond angle of water is 104.5 degree. So, water has the highest bond angle, students. Now, question now 3. Which is the shape of p orbital? The shape of p orbital is dumbbell shape. Students, to give you a clear concept about the orbital shape of s, p and d orbitals, I would like to show you the figures in the whiteboard. So look at the whiteboard and see the all figures. S is actually spherical shape, p dumbbell shape, and d double dumbbell shape. Which has the least electronegativity? Dear students, from the definition of electronegativity, you know that the relative capacity of pulling bond pair electron to itself in a molecule is called electronegativity. And all of you know that helium, this is an inert gas, and inert gas would not like to donate or accept or share any electron with any atom. That's why their electronegativity is 0. In that sense, the choice A is correct. Look at the question number 5. Boron trifluoride. The central atom of boron trifluoride is boron and it takes part in sp2 hybridization. Students, now you can see the orbital figure of boron trifluoride, and from the orbital figure you can understand easily that boron trifluoride takes part in sp2 hybridization. And dear students, boron trifluoride also form coordinate bond with ammonia. All of you know that if the required number of electrons are supplied by an ion or atom or molecule, and the another ion or molecule accepts the supplied electrons from the donor molecule or ion to form a covalent bond. This type of covalent bond is known as coordinate bond. Students, now I would like to show you the bond formation, coordinate bond formation between boron trifluoride and ammonia. This is actually the Lewis structure of boron trifluoride. So from the description it can be understood easily. The choice 1 and choice 3 are correct. So choice B is correct. Which one is insoluble in water? This is glucose due to the presence of oxygen. It is actually polar, as glucose is a little bit polar. It is soluble in water. All of you know that water is also polar solvent, and at the same reason, this is sugar. This sugar also a little bit polar. That's why it dissolves in water. And sodium chloride. Students, all of you know that sodium chloride is a pure ionic compound. That's why it is soluble in water. But silicon dioxide, you know that silicon dioxide is a giant molecule. It has a giant structure, and by the dipole-dipole attraction force, silicon dioxide form a giant structure, and that's why it does not show any ionic characteristics. So silicon dioxide is insoluble in water. Dear students, I would like to show you the structure of silicon dioxide in the whiteboard.